Hello friends, in this lecture we will see multiple axis operation, and that is the variable streamline operation. So this is the part I have, and one tool I have already defined. So I will start from the basic from the beginning. So I'm going to create new workpiece, and this time my operation type is multi-axis and workpiece, and this workpiece under this MCS. Okay, and workpiece 1 is this, no problem. Okay, my part is this. Okay, and blank I'm using bounding cylinder, and my axis is along the X. Okay, and reset. If you want to increase the length of this cylinder, you can increase. Okay, reset. For if you want to clamp at the uh, last point of this cylinder, so we can add. Okay, so height is this one, so I'm going to change 350. Okay, and drag this, it will shift, so we have the space to clamp it in the chuck. I don't want to show it blank. Okay, so my workpiece is defined. Now I want a new MCS like G54. Okay, and under this MCS, this under this workpiece 1. Okay, and it should be here at the starting. So this is Z is the tool direction, and X is for rotary axis, and that will come A axis. Okay, the tool will, this part will move along the about the X. So rotary axis, fourth axis will come C. Okay, so here no need for this. If you want to delete it. Okay, under this MCS I want to create operation, and my first operation is variable streamline. We can use this, is just similar to the streamline, but here the tool direction will be in variable direction. So this workpiece, and here the tool is mil 10. I'm going to use this mil 10, and from here this MCS1 is my geometry, and I want to do uh, roughing. Okay, first specify the cut area. So this is my cut area. Okay, part stock is 1, so I'm changing it to 0.5. My drive method is streamline, and if you will see, the all the option are the same as we have done in 3 axis streamline. These all are the same, only the change is projection vector. This is the projection vector, and this projection vector is by default along tool axis. So my tool axis is Z, so it will not work here. Let's see the first tool axis. My tool axis is normal to part. Okay, so my part is cylindrical, so tool axis will be normal to my part, this part surface cylindrical. Okay, and go to main, and my this time I'm going to select towards line, and this vector is showing you. So click, this is the direction, my point is center. Okay, now if you want to highlight it, highlight this vector. See, these are the projection vector here, you can see. Okay, and let's generate. And if we are using the cylindrical object, so that time we can change this common equivalence to cylinder. Okay, that's enough. Generate. Okay, let's see the verification. zigzag. This pattern is zigzag, so tool is working according to the zigzag. And here I can apply multi-depth. Multi-depth option is there. If you want to check it, suppose I'm assuming my stock is 2 and cut is 1, so 2 toolpath will come. In 2 level, this depth will cut. First level and second level. Let's zoom it. I will show you. See, okay. And from the main in method we have already covered, but here we have this helical or spiral. So I'm using this spiral. I'm using helical and spiral. So in this geometry, the helical will work. So generate it, and you will see the tool is starting from here, and it will cut up to the last. So toolpath will generate in helical manner, and non-cutting move is also in cylindrical manner. See, okay. And if we will see this in 3D dynamic, you will get the better idea how it is working. A little bit slower. See, helical pattern. We can control this step over. Okay, that is not an issue. And 0.5 mm material will be left on the bottom. See, here we have some material on the wall, so I want to finish it. And before this, I'm going to change. Okay, no problem, just okay, then we will see. Okay, so next option is this contour profile. We have already seen in planar milling one profile is there. Okay, this one also the profile, and it is also the profile for 2D operation. And in 3D we have seen this profile 3D and solid profile 3D. Okay, this will work for 3D, and for multiple axis we can use this operation. Okay, contour profile. So I'm using this contour profile. Okay, and it is okay, and I'm using finishing operation. Okay, and select the floor geometry. Wait, it takes time. Okay, it is selected. If it is not highlighting, just change to tangent base. Okay, and see the wall. Okay, here we have the two wall. So this toolpath will generate according to the wall. Stock, I don't want any stock, and axis, no need to change any axis. Here we can add multiple side and multi depth. So we will see, just generate first. Okay, it is coming from very far. So first I'm adding multiple side, and I'm assuming 2 mm as a stock and increment as 1.0. And from the non-cutting move, same, this cylinder, and my center is this, and vector is this. Okay, and 60 is a retract value. Okay, and now generate it again. Now I have used two passes, so it will generate two passes near the wall. Okay, and if I want to add the depth, so I can add my depth, same 2, increment 1, and generate. Okay, let's see the verification in 3D. It is computing IPW. So it is cutting up to the floor. So this material which is left here is zero point 0.5 because we have done roughing operation in our first operation in variable streamline. We have done roughing operation, that's why this material is here. Okay, so okay, and again okay. So this is the variable streamline operation.